Hello students, welcome to Long Edutech. Today I brought here class 9 science chapter 1, that is the matters in our surroundings. Okay, so let us see now. So you know the matters. Matters is the anythings, as we already know, that is the anythings that occupies space and has mass and is held by sense. Okay, it's simply called as matter. Some examples of the matter: stone, water, oxygen, glass, whatever we see in our surroundings, they can be categorized as the matters. Okay. Yeah, and now here comes to see, according to the Indian scientists, that is ancient philosophers, it is given that matter is a form of the 5 basic elements. And that basic elements are given the name that is the Panchatattva. The Panchatattva. Okay, what are Panchatattva? The Panchatattva are the air, earth, that is the land, okay, the mitti, okay, and fire, sky, and water. Okay, so these are according to the Indian ancient philosophers. Okay, so what are the Panchatattva? Then it should be air, earth, fire, sky, and water. Okay, so here you know the matters. The matters already exist here, and some characteristics, features will be there for the matter, right? So what are the characteristics of the particles of the matters? Okay, matters are made up of the very tiny particles, as you know. Matters are made up of tiny particles. Okay. Second one, vacant space, that is intermolecular space, exists between the particles. As we know, matters are made up of the particle, and if we see, then between the particles here, there are some space. They are not completely very tightly packed, you know, that means, right? Yeah, it will depends according to the types of the matters. And number 3 is the particles are in continuous motions. Every particles in this universe, they are always in motions. Okay, and even our continents, it used to believe that our continents, they are together long years before, but due to the movements of the tectonic plates or the movements of the plate boundaries of the earth, they are far apart, and it makes the 7 continents. It is used to believe, and also believe that one day they will collide each other. Who knows? That time will be ends of the earth again. Yeah. Next is particles are held together by interparticles or intermolecular force of attractions. For the particles to tie up, okay, so it needs some force, and that force will call as the intermolecular force or interparticular force of attractions. Okay. Yeah, these are the characteristics of the particles of the matters. Okay, so here, what are the basis of the classification of the types of matter? On what basis we used to classify the matters? That's only. Okay, so the matters are classified. Number 1, based upon the particle arrangement. How the particles in matters, they are arranged to form that matter. So we'll see on these things. That means scientists see all these things. Second point, based upon energy of the particle. That is, the particles, matters are made up of the particles, and in between the particles, there will be some energy which hold together. Yeah. And number 3rd one is that based upon the distance between the particle. Okay, the particle, how far the particles are there. Okay, so these are the 3 important bases of the classifications of the types of the matter. Okay, and now comes to see there are the 5 states of matter. Okay, generally we know the 3 states of matters. Okay, what are they? Solids, liquids, and gas. Okay, these are common amongst us, and we see in our day-to-day life only. Okay, and some others 2 types of the matters are there that we find difficult to see all those things in our life. What are they? Number 4 is plasma and Another one is the Bose-Einstein condensate. That is, the Bose is none others. J.C. Bose, the Indian philosophers, and Einstein. He took the Einstein theorem to prove his substance or matters. Okay, so given the name Bose-Einstein condensate. Yeah, let us discuss one by one all these states of the matters. Okay, see now. So first of all, here it comes the solids. What are solids? Okay, solids are the state of matter which have mass, occupy space, and have definite volume. Okay, example to the stone, steel, and many things. Even we are also solids, right? Yeah, some portions are liquid also, no problem. Yeah, so state of matter that have the mass, occupy space, and have definite volume. Okay, so other things that is characteristics we'll discuss now. Okay, first before going that one, let us see how is it the solid. This is the solid particles, and if we magnify this one, what you see here, we magnify these portions, and then what you see here, there are a lot, there is the space. There is space between them, right? And these particles, amongst all these particles, they are bind together, and there is space there, right? Yeah, and this space and particles, this space is called the interparticle space, or the void, okay, or intermolecular space also we call. Okay, and in between the particles, they are tightly bind together, and this is the interparticle force of attraction or intermolecular force of attractions. Okay, you must know that solid have the high intermolecular force of attraction, and the interparticle space is less. Okay, because if higher the interparticular force of attraction, lower will be the interparticular space, and smaller the interparticle or intermolecular force of attraction, that is interparticular space will be large or more. Okay, let us see now the properties or I'd say the characteristics of the solids. The first one, they have fixed mass, volume, and shape. Solid generally have the fixed shape. Interparticular space are less. As we have seen there, the interparticular space are very less. They are incompressible. Interparticular space is less, then definitely we cannot compress. Like, still, can you compress? No. But if we hammer it, it can change a little bit shape, right? That means by giving the pressure, we can change the state of the matter, right? So we'll discuss later. And they have a high density and do not diffuse. Okay. Diffusion is the particles of the matters that get mixed with the air only, but the solid cannot mix with the air. Okay, high density also, and they have the strongest interparticle force of attractions than the liquid and the gases. And see, constituent particles are very closely packed. That's why they cannot be always in motions. Okay, so these are the characteristics of the solids. Okay, and now we will go to the liquids. Okay, so liquids are the states of matter which have the mass, occupy space, and have definite volume, but do not have definite shape. Okay, and it takes the shape of the container where they kept. For example, say the water. If we put the water in the glass, then it takes the shape of the glass. If we put in the plate, then it takes the shape of the plate, isn't it? If we put it in a bucket, it takes the shape of the bucket, right? So where we place, it depends, okay, the shape of the liquids. So it do not have the definite shape. Okay, so let us see the particles here. This is liquid particles, and they are loosely packed, Okay, and that's why their intermolecular space is more and intermolecular force of attraction is less. Large intermolecular space than solid. Okay, and a weak intermolecular particles of attraction. If it is weak, then they will not bind together very closely, right? So this is the characteristics we have to discuss now. Okay, let's go now. The characteristics of the liquids. Number 1, they do not have fixed shape, okay, but have the fixed volume and mass. Okay, I already explained you that they do not have fixed shape and take the shape of the container, right? Second one, the interparticles density distance are larger than solid. That is interparticular space, okay, that is the distance are larger than the solids as compared to the solid, and they are almost incompressibles. Liquid are also almost incompressibles, okay, under the ordinary conditions, and density is lower than a solid and it can diffuse. Okay, the density of the liquids are lower than the solid and they can diffuse. Just like water vapor, right? During the winter time, water vapor get diffused in the atmosphere and it makes fogs, clouds and all, right? Yeah. And number 5, interparticular force of attractions are weaker than solids. Okay, they have a weak interparticular force of attraction. If it is weak, larger will be the intermolecular space, I told you, right? Yeah. Next comes to the constituent particles are less closely packed. Okay, so these are the characteristics of the liquids that we have to know. Okay, and now we can proceed to the gases or gas. Okay, gases are the states of matter which do not have the fixed shape and volume. Okay, which do not have fixed shape and volume. Okay, like air. Our room is filled with air, right? So what is the shape? Is the shape of the air inside the room is like a room, a rectangle or a cube? No. Yeah, and does not have the fixed volume also. Okay, but it has mass. Okay, don't get confused. It has mass. If we fill in our tube or you say in the balloons, it has some mass. Okay, that's why it falls down. And also in the vehicles tires. Okay, tires of the vehicles, they are also, when you fill with the air, then it has some weight there, right? Yeah. Okay, let's see. This is the gaseous particle. Intermolecular space is very large, and interstitial space, or you say the molecular space, is also large, isn't it? Yeah. So these things we have to know: large interparticular space and weak intermolecular particles, or you say the force of attractions. Okay, so characteristics of the gases: they have neither fixed shape nor fixed volume. Interparticle distance are largest among the solids and the liquids. They are highly compressibles. Okay, they can be compressed very easily. So, in terms of the compressibility, the gases will be higher than the liquid, and liquid are higher than the solids. That's we can write in that way. Sometimes in the questions they will give the examples by giving the milk, carbon dioxide, and they still write the decreasing order or increasing order of the compressibilities. Like that also can give. Okay, and the number 4, density is least and diffuse easily. Okay, they can diffuse very easily. That's why if we use a body spray or perfumes somewhere in the corner of the room, then the smell gets spread over a long distance, right? This is the application spot. Okay, and all these questions will come again. And even though if we cook the food, okay, the cooked food, when your mom's cook the food there in the kitchens, then the smell reaches to your room. How? Okay, so that is the cooked foods, they get vaporized, and when they get vaporized, they diffuse in the air, and it reaches to the long distance. That is, they can stretch over. Okay, yeah. And number 5, the interparticle force of attractions are weakest than from the liquid and solid. And number Last point, the constituent particles are free to move about. Okay, they are always moving, and thus the wall of the container where they place. Okay, keep in mind the gases, they always are, they are in motion, and thus the wall of the container. These are the stats. And number 4, here we can discuss the plasma. Okay, the plasma non-evaluatives. Okay, so it's not based on your NCERT books and all. Okay, so it's okay. The plasma is an ionized gas. Okay, is an ionized gas. When a chlorine get ionized, then chlorine changes to Cl plus or minus. Cl minus, so Cl will be minus. All right. So like that ionized gases. Okay. And a plasma is a very good conductor of electricity and is affected by magnetic field. Okay, magnetic fields it will affect. That means it will deflect the magnetic needles when we place near the plasma, because they contain ionized ions are charged particles only. That's only. And the plasma like gases have an indefinite shape and an indefinite volume. Okay. Like gases, they don't have the indefinite shape and the indefinite volume. Okay, so this is all about the plasma. Okay, example like ionized gas, I told you just now. Say the chlorine gas, iodine gas. Okay, but they will be in the ionic forms. Okay, and the next is the Bose-Einstein condensate. Okay, so this is also non-evaluative. That it will not count in the exams points of view. Okay, so BEC is nothing, that is the Bose-Einstein condensate. Okay, is a state of matter that can arise at very low temperature. Okay, they can arise at a very low temperature only. This Bose-Einstein condensate. Okay, the scientist who works with the Bose-Einstein condensate received a Nobel Prize for their work in 1995. Okay, the Bose-Einstein condensate is all about molecules that are really close to each other, even closer than atoms in a solid. Okay, very thick, very dense substance. Okay, so which are even more than from the atoms in as solids. Okay, so this is all about today's class.